Good evening, all of you. So, in day 23, we are going to discuss about data structures. Like, what is the data structures? So, in day 23, we are going to discuss about definition of a data structures, and after that, we are going to discuss about classification of a data structures or types of a data structures, and after that, we are going to discuss about linked list. So, just I will give a overview. So, data structure data can be arrangement of data in computer's memory is called as a data structures. So with help of these data structures, we are going to arrange the data in computer's memory. So that is the definition of a data structures, and it can be classified into two types: primitive data structures or primary data structures, and non-primitive or secondary data structures. And again, the secondary data structures can be classified into two types: static data structures and dynamic data structures. And the static data structures examples are arrays and structures. And the dynamic data structures can be also defined classified into two types: so linear data structures and non-linear data structures. So what is a linear and what is a non-linear? So if the data structures is going to use sequential memory allocation. So if the data structure is going to use sequential memory allocation, so then the data structures is called as a linear data structures. So if the data structures is going to use a non-sequential memory location, then it is called as a non-linear data structures. So the linear data structures will be comes under like linked list and stacks, queues. So all will be comes under linear data structures. And here the linked list will be have a different types, like it may be a single linked list or double linked list, or it may be a circular linked list. And again, this circular linked list can be classified into circular single linked list and circular double linked list. And whereas in the non-linear data structures will be comes under trees and graphs. So the trees and graphs will be an example for non-linear data structures. So that's what we are going to discuss in the previous class, and also we are going to discuss in the day 23 about a linked list. So in what is a linked list? So linked list or list is an ordered collection of elements. So linked list or list is an ordered collection of elements, and each element in the list is referred to as a node, and each node contains two fields. So what are there? It contains a data field and it contains address of the next node or link field. So the data field contains data, actual data of the node or element. So whereas in a link field, it contains the address of the next node. So the link field or address field contain the address of the next node. So whereas the data field contain actual data of the element to be stored into the linked list. And this is a linked list representation. So here it contain three nodes, that is a first node, second node and a third node. So it contain a data field, it contain number like 10 and 75 and 100, and it contain the address of the next node of node 1. It contain address of the second node, and the address of the next node for a second node contain address of the third node, and the address of the third node contain address of the fourth node. So in this example there is no fourth node, so that's why for the third node it contain only null address. For third node it contain null address. So the null address indicate that it is the end of the node, or it is the last of the last node in the linked list. And similarly, the address of the first node, which will be stored into the head pointer. So the head pointer contain address of the, so this is address of the first node. So this address is going to store into the head pointer. So the head pointer always contain starting node address. So these are the different types of addresses we have discussed in the previous class, that is called external address. So the what is the external address? So if the node contain the head pointer contain external address, the head pointer contain external address, and whereas internal address, each and every node contain a address is called as a internal address, and null address, the null address contain or it indicates that it is a end of the node. So the last node contain null address, and it will be indicate that it is the end of the node in a linked list. So the external node, the external address contain head pointer, that is the starting node of the linked list, which will be stored into the head pointer. So that address can be called as a external address. So whereas an internal address, each and every node contain a address of the another node. So that address is called as a internal address, and whereas the null address, which will be stored at last node in the linked list. So the null means that it is end of the node in a linked list. So these are the different types of addresses you can use it in a linked list. So these are the different types of linked list. So single linked list, double linked list, and circular linked list. So in day 23, you are going to discuss about a single linked list and followed by example. So these are the operations can be done on a linked list. So that is creating a node, and after that inserting a nodes, and the insertion can be carried out in three places. So inserting at the beginning of the node, or inserting at the last position of the node, or inserting at the middle position of the node, and deletion of a node. And again this can be performed in three ways. So deleting at first node, or deleting at last node, or deleting a intermediate node in a linked list. And after that can display the number of elements in a linked list, or number of nodes in a linked list. And last one is a count. So how many nodes will be there after performing insertion and deletion operation? How many nodes will be left out in the linked list? With help of a count operation, we will go and count the number of nodes in a linked list. So these are the different types of operations can be done on a single linked list. So yesterday I explained how we will going to create a linked list, and after that how we will going to insert with help of a diagrams I explained in the previous class. So just I will skip all this. Okay, now in day 24, so it is a day 24. Today class we will go and discuss about double linked list. So we will go and discuss today about a double linked list. So what is the difference between a single linked list and a double linked list? So in a single linked list, we will going to travel. We will going to travel from head pointer to first node, second node, third node, and so on up to end of the node. So but you don't want to travel from last node to first node. So that means you can travel from only one direction, that is only from forward direction only. You are not going to travel from in a reverse order. So that is a drawback of using a single linked list. So for overcome the drawback, that will be going to solve by the double linked list. So in double linked list, we will go and travel from forward direction as well as in backward direction also, or reverse direction. So that will be possible in a double linked list. And same operations. So what are the operations can be done on a single linked list? So same operations will be used for creating a double linked list. So that is a creation of a list, and inserting of a nodes, and again insertion will be carried out in three places. Inserting at first position, or inserting at last position, or inserting at middle position, and deletion. So deleting at first position, deleting at last position and deleting at intermediate node, or travel. You can travel in a linked list. So while traveling from forward direction or reverse direction, we will go and display the number of elements in a linked list. And count operation, we will go and perform how many values are there, how many values will be left out after performing insertion and deletion operation. So what are the operations can be done on a single linked list? So same operation will be also done on the double linked list also. So how we're going to create a list, a double linked list? So first we need to create a node. So that means you can take one node name temp node, and we're going to create a nodes by using some insertions like reading the details from node from the user, and connecting to node with the list. And next one is insertion. So the insertion of a node can be done in three ways. So inserting as a first node, inserting as a last node, or inserting an intermediate node in the linked list. So now this is an example. So in a single linked list, it contains only two fields, that is a data field and address of the next node. So in a single linked list, the node contains only two fields, that is a data field and followed by address of the next node. So whereas in a double linked list, it contains three fields. So that is a address of the previous node. So address of the previous node and data or number or data field, and followed by address of the next node. I hope you will be understanding what I am saying. So in a double linked list, it contains three fields. One is called address of the previous node, and data field and address of the next node. So whereas in a single linked list, it contains only two fields. So data field and address of the next node. So that is the one more difference between a single linked list and a double linked list. So if you have any, please ask me. If you have any doubts, you can ask me. So what is the difference between a single linked list and double linked list? So in a single linked list, we will go and travel from forward direction, from head pointer to last node. But it's not possible to travel from backward direction. So that means last node to first node. And similarly, in a single linked list, the node contains only two fields. So that is a data field and address of the next node. So whereas in a double linked list, it contains three fields. So the first field contains address of the previous node, and the second field contains data field. So that means what is the data we are going to read from the keyboard. So that data will be stored into the middle field, that is the data field, and the last node contain address of the next node. I hope you will be understanding. So address of the previous node and address of the next node, and middle field contain data. So that is another difference between a single linked list and double linked list. So now here I created three nodes. Uh, the first node the first node address is FEA2. So that address which will going to store into the head pointer. So this is a head pointer. So the head pointer always contain address of the first node. And what about in why I mentioned here null address? So why? Because there is no previous address, or there is no previous node. So before 5 there is no nodes. Before 5 there is no nodes. So that's why I don't know address of the previous node. So that's why the starting node always contain null address. And the next one, I am inserting a data 5 into the data field, and after that address of the next node. So what is the address of the next node? That is the second node address, which will go and store into the first node. And similarly, now coming into here, so now what is the address of the second node? That is F003. Okay, now clear? F003. Now what is the second node previous address? What is the address of the previous node in a second node? So that is a FEA2 is a previous node address. So that address will be stored into the uh, second node and followed by data. So here I am reading a data will be 33 and followed by what is the address of the next node. So the third node address will be stored into the second node. So next one, coming into third node. So for third node, what is the address of the previous node? That is a F003. F003, which will go and store for a third node previous address field, and the data will be 89. And what is the address of the next node? There is no next node in my linked list. That's why I am writing a null address. I hope you will be understanding what I am saying. So if you know the address of the next node, then it will go pointing from forward direction, and if you know the address of the previous node, then it will go pointing from second node to first node. So it will be a two directional, bidirectional. So you can store the address of the next node and you can store the address of the previous node. So that's why it will pointing from forward direction as well as in backward direction. So that's why I said that you can travel from forward direction as well as you can travel from reverse direction. That will be possible in double linked list. So whereas in single linked list it is not possible. So now here I am taking a one new node. So that node can be inserted into the before 5. So before 5 I want to insert the 74. Then what I have to do? So for 74, you can store the address of the next node. That is what is the address of the fifth element, that is the FEA2. So that address will be stored into the in the place of null. So whenever there will be no address of the next node, so then it will be pointing from next node. I mean you can pointing from new node to new node. So this is a new node to next node. And similarly, if you know the address, the second node know the address of the newly created address, then it will be connected from second node to first node. So that is the difference between single linked list and double linked list. So like that, we will going to insert the elements into the linked list. I hope you will be understanding what I am saying. So the double linked list contains 3 fields. So address of the previous node and data field and address of the next node. So simple. So these are 3 fields. So for performing inserting at last node. So if you want inserting at last node, then you will be travel from first node to second node to third node, and after reaching to the last node, now you have to store the address of the this address, that is a newly created node into previous address field. And similarly in for newly created previous node will be address will be stored for the third node. So the third node address will be stored into the fourth node, and the fourth node address will be stored into the third node. So like that we will going to perform inserting at first position, or inserting at last position, or inserting at a middle position. And similarly you can perform deletion. So deleting at the first node, deleting at the last node, or deleting at the intermediate node. So this is a operation. So if you want delete a first node, so then what you have to do? So directly you have to pointing the head pointer will be point out to the next node. That means that the address of the second node can be stored into the head pointer. So the address of the second node can be points to the head pointer. After that you can by using a free function you can remove the first node. So like that we will going to remove the elements if it is a first node or if it is a last node. Okay, and if it is an intermediate node, so we will going to remove like this. And next one, travel. So in double linked list you can travel from starting node to end of the node, and similarly you can travel from last node to first node also. So why? Because it contain forward direction, the list contain forward direction as well as backward direction. So the forward direction contain address of the next node, and the backward direction contain address of the previous node. And finally we can perform count operation. How many nodes are there in a linked list? You need to count. So that is about a double linked list. So now I will go to explain one example. So it is a double linked list example. So here in a previous single linked list, I have only two fields, that is a address of the next node and followed by data field. So whereas now it is a double linked list, so it contains another field is called previous node. So struct node and followed by star previous node. So it is a pointer variable. So why you are why you are taking a pointer variable? So because it is a address field. So because it is address field, that's why you have to represent as a pointer variable, and it is a self-referential structure. Why? Because we're going to use the same structure name inside of structure. So that's why it is called as a self-referential structure. So in this example, in previous example, I have only data field and next field only. For single linked list, it contains only data field and next field, whereas in a double linked list, it contains one more field is called address of the previous node. And these are the operations: insertion of beginning, inserting at beginning, inserting at last, or inserting at intermediate, and deleting at the beginning, deleting at last, and deleting at a specified position. And after that, you can display the elements, or you can search the elements also. So this is a code for double linked list. So here I'm using a switch case for performing all these operations. So I'm going to use a operations. So this is a code for allocating the memory for the newly created node. After that, you can read the data from the newly created node, and after that we'll go to insert that into the if it is a first node is a if the first node is a first node as well as last node. So this is a code for you can add to the linked list. And if the linked list contain already it contain two nodes, then uh, it is a code for inserting at a previous node, I mean a first node, and similarly inserting at last node. So this code will be very easy if you know once how we're going to perform insertion operation or deletion operation or searching operation or displaying operation, or how to create a nodes. So if you know, it will be very easy to write. Okay, it contain a lengthy program, but if you once you can understand the logic of how we'll going to perform insertion operation or deletion operation, then it will be very easy for understanding the program. So this is for last node. So for that, what you have to do, I'm going to create new node, and I'm going to allocate the memory for the new node. So after that I'm going to insert this node as a last node. So for that, what you have to do, so after creating a new node, now I'm going to insert the data into data field, and uh, followed by so if it is a if it is a head equal to null, or if it is a the linked list contain only one node, so we'll go and write uh, po uh, pointer points next is equal to null, and pointer points to previous equal to null. So initially for a newly created node, the previous node and next node, it contain null address. So after that you can use this code for inserting a last position. So if you want inserting at a last position, then you have to move from first node, second node, third node, and so on, uh, last but one node. So after reaching to the last but one node, now you have to inserting a new node. So this is a code for inserting at a last position, and this is a code for you can travel from first node, second node, third node, and so on up to it's not equal to null. And this is a code for inserting at a intermediate node, and this is a code for creating and allocating memory space. And if you want inserting any in any position, you have to read location from the keyboard. So based on that location, we're going to insert the data. So based on that location, we're going to insert the data into the intermediate node. And similarly, you can perform deletion operation. So deleting at first node, deleting at last node, and deleting at middle position. And after that, display. So for displaying, just you can travel from first node, second node, third node, and so on. And it will be also possible to print the list, linked list in reverse order also. So next is searching operation. So I want searching whether the particular element is available in the linked list or not. So if it is available, then just I want display the so where the position will be available that element. So otherwise so simply I want write is not available. So that is a simple code. So once you can understand the how logic or how the operation can be done on double linked list, so you have tried almost you have tried your own code. So in the examination, it's not by heart the entire program. So if you know the operations how will going to perform on double linked list, then you have tried in our own logic in the examination. So that is about a double linked list. So I want just run my code. So just you can open the Turbo C++. So I already saved my file in my Turbo C bin folder. So that is a double linked list. So this is a file name. So I'm going to run the program with help of Alt F9. So there is no compilation errors. Now you can press Ctrl F9 for executing of this program. So now this is a menu. So this is a menu. It will go on display. Now it will go to ask enter your choice. So you can perform insertion in the beginning, inserting at last, inserting at any random location, or deleting from beginning, deleting from last, or deleting node after the given data, or searching, or you can display. And if you don't want, you can press exit. So if you give a 9, it will be exit. So let us see here. I want inserting. So I'm going to perform insertion operation at beginning. Then I will take choice 1 and my data will be 1. Now you can display the you can display after inserting at beginning. Now you can display. For displaying you have to use choice will be 8. So now see here. So now in the linked list it contain only only one element. I hope you'll be understanding. You can observe the screen. So I'm entering choice is 8. Then it will printing value will be 1. So next one, I'm going to choose first choice, and I will enter next element is 2. And similarly, I will be choose first option. Then I will be enter 3. Now you can display 8. Now see here. So now the now the double linked list contain 3 to 1. 3 to 1 or 1 to 3. So 1 is a first position and 2 is a second position and 3 is a third position. So if it is a reverse order, 3 is a first position and 2 is a second position and 1 is a third position. So that is a inserting at beginning. Now I want inserting at last. So you can go for option 2 and I will take element 4 and display. Now see here. So what is the first node? What is the last node in a double linked list? So the list will be like this. So it will be first node is a 3, second node is a 2 and third node is a 1. So now I am using second option, inserting at last position. So I am taking data is 4. Then the 4 will be inserted after 1. That is the last position. So similarly, you can perform deletion operation. So for example, I want delete from beginning. That is, I want delete a third node or third element. Then you can go for choice 4. So it will be deleted, no deleted, and you can display. Now see here. So the 3 will be deleted. Now in the linked list, it contains 214 only. 214. Now let us perform searching operation 7. So enter the item you want search. So how many elements are there? Only 3 elements. The element numbers are 214. Now I want to looking for 4. Whether the 4 is there in my linked list or not. So see here where the 4 will be found at last position. That is a third position. So the 4 item found at location 3. Okay, now clear what I am saying? And after that searching is over and showing, you can use the option 8. So it contains 3 nodes, 2 1 4, and if all operations will be done successfully, in this example I am not going to implement the traveling, and I am not going to implement the count operation. So it is also possible you can implement a travel. You can travel from first position to last node, last position to first position, and so on. And similarly, it is also possible to perform count operations also. So that's all about the double linked list. And if you have any doubts, you can post your query in the chat box. Now for exiting from this window, you can give choice 9. Now it will be exited. So that is about the double linked list. So any doubts? If you have any doubts, you can post your query in the chat box. So that's all about today class. So in the next session, we'll go and discuss about circular linked list. So if you have any doubts, so please post your query in the chat box. So I will try to answer your queries. So in the next session, we will go and discuss about circular linked list. And after completion of this circular linked list, we will going to see what are the different types of applications of linked list. And after that, we will go and discuss about stack in the next session. So if you have any doubts on single linked list and double linked list, you can post your query in the chat box. So I will try to answer your queries. So that's all about today's session. And if you have any doubts, you can post in the chat box. So any doubts? So if you like this session, so you can subscribe. You can subscribe my channel, or you can press thumbs up button. So if you like this lecture today, you can subscribe my channel as well as you can click on a thumbs up button. So that's all about today's session, and we'll go and meet in the uh, tomorrow in a day 25. So thank you.